and co-authored 50 plus research papers, which has heavily cited by researchers all over the country. He has published research papers in various reputed international journals, including IEEE, IET, Elsevier, Springer, and many more. He is also an reviewer of these particular journals. He has guided several PhD scholars, around 20 MTech scholars, and 80 plus BTech students' thesis. And he is presently serving as the head of the Department of Electronics and Communication Engineering, NIT Raipur. So welcome you, sir, to this faculty development program on 5G and wireless communication.
Thank you.
So
Thank you, sir.
over to you, sir.
Thank you. Thank you, Nando sir. I have a long association with Nando sir, I think more than around 15 years.
Yes,
And
we both did our PhD together at IIT Bhubaneswar.
right,
Yes.
right.
So
And
it has been a long association.
thank you, sir.
Thank
Thanks to all of you, as well as the organizers, as well as the management for giving me this opportunity. So today, what I basically good evening. Already it is around 4 p.m. I think good afternoon and good evening to all of you. So I want to discuss about this basically the optical communication and how it is useful for our 5G and beyond wireless communication system. Oh. So if you will see the 5G and beyond, the basically the different generation of wireless communication systems, I think since so many sessions you might have listened, and out of all you can tell different generation, the important is one of the important parameter is data rate. Data rate or speed of this communication, speed of the internet, and speed of this entire system. So if you will see, and what is happening, the optical, I think those who have studied in optical communication might be the most advantage of optical is the higher bandwidth. Theoretically, the bandwidth of the optical fiber is infinity, all of you know. And because the bandwidth is infinity, definitely it can only provide very faster data rate. And data rate is an important parameter for higher generation, maybe 5G as well as beyond 6G or 7G maybe also. And because the bandwidth is infinity of optical fiber, definitely you can tell that it will provide very high speed communication. And one more parameter of any higher generation or very high advanced communication system is power. And optical systems all works with laser. I think all of you know about it, light. And laser, LED, these are all works very low power in the range of milliwatt. So that is, if you will see the power and bandwidth, optical systems provides very high bandwidth with a consumption of very low power. So that is why for upcoming advanced communication system, optical plays a major role. Okay. So this is what about this, just a briefing about why we have or I have chosen this topic in brief. So the outline of my presentation will be like this. Like first of all, we'll go for again the introduction, 5G and beyond wireless technology, and why especially optical communication. No doubt already I have highlighted regarding the data rate, regarding the you can tell power. The rest all also we will discuss. And fiber optics, there are various types of optical communication. Optical means people used to think that is only fiber, but it is not only fiber. It may be free space, inter-satellite optical communication, underwater communication, deep space communication. There are so many optical communications systems which plays a major role in advanced wireless technology, which we will discuss. Then about because of the higher bandwidth or huge bandwidth or theoretically infinite bandwidth, DWDM system, dense wavelength division, multiplexing system plays a major role. About that multiplexing system, we will discuss. And one of the major, you can tell, drawback of this or the challenge which is lying till now in this state-of-art research in this optical communication is nonlinear effects. Out of that, one nonlinear effect is FWM, four-way mixing, that I will highlight here. And then we will go for hybrid optical systems also, which is a combination of fiber, free space, as well as inter-satellite and all. Then we will go for certain simulation and its results, discussion, conclusion, and references. So anywhere anybody is having any doubts, please interrupt me. I will be happy to answer your questions, queries, whatever it is there. No doubt at the end we will have a question and answer session. But in between any doubts, please interrupt me. It is not an issue. So I think participants can unmute and ask questions. Am I right? Nanda sir or Ravi sir? Okay. So I think option might have given. So that is why anywhere, any problem you will be facing, just interrupt me. You can ask the question and we can proceed. So if you see the communication system that source to destination, basically if you go for the basics, no doubt we will have to have this optical communication in advanced wireless communication system. But if you see the basics, there are two types of you can say scenario where we have source, another is also called destination. And source to destination, what we need to transfer the data. In between source to destination, what we do have is called our communication channel. So that is why in simple, what is a communication? Communication means transmission of information from one place to another place. And the place where information is available is called source. And where we need to communicate is called our destination. In between source to destination, we have called our communication channel. Okay. And as far as the communication channel is concerned, this optical or the communication is various types, which is well known to you, which is no doubt we will again go for its briefing. That one is wire communication, wireless communication, waveguide, cable communication, and that also comes internet as well as like our satellite mobile communication. Then next one is called our hybrid communication. Hybrid communication is a combination of what is hybrid communication? It is a combination of wire plus wireless plus fiber optics cable. And why you are going for combination? Because each and every system like wire communication has its advantage and disadvantage. And what is the advantage of wire communication is the loss is less or it is a point-to-point communication. And but the one demerit of that one is you cannot go for point to multi-point like wireless. In wireless, we can go for point to multi-point communication. A very simple example is our landline telephone and mobile phone. So people always prefer mobile phone rather than landline telephone. Why? Because mobile phone anywhere you can the user has the mobility facility. The user can move here and there and get the facility. But if you go for landline telephone, it is only point to point. Only point to. That is why what I mean to say, wire communication is not suitable at the what front end as well as back end. That is also called last mile and first mile problem in communication. So last mile and first mile, the communication should be completely wireless so that the user will have the ability to move here and there and get the communication facility. In the same way, wireless communication has the demerit that it cannot be covered for a long distance. For long distance coverage, we need to go for again like fiber optics communication and all. So that is why wireless has the advantage of mobility, but the disadvantage of long distance communication. Wire communication is possible, is good for long distance, but not for multi-point or broadcasting purpose. So that is why all the systems in reality are nothing but hybrid systems, where part of the channel is wire communication and another part is wireless communication. Next, we will go for it. That what is this 5G? 5G and beyond wireless is a global wireless standard. I think all of you know. After 1G, 2G, 3G, 4G, then it comes 5G, and next up thing what we are discussing is about 6G also. So what is happening here? What in simple, how you will classify the different generations? The classification is very simple. That if you will see about the data rate, 1G has very low data rate, very low speed communication. Then as the speed of the communication is increased, 1G moved to 2G, then 2G moved to 3G, 4G, and 5G like this. So that is why different generations will have. What I mean to say in simple is nothing but different data rate. Where if the data rate is increased like anything, then 1G moves to 2G, 2G moves to 3G and 4G. No doubt so many other parameters are also there. But what I mean to say, the data rate or communication speed or the capacity of this communication plays a major role for moving from one generation to next generation in wireless technology. And 5G enables a new kind of network that is designed to connect virtually everyone, everything together, including machines, objects, and devices. Okay, and if you'll see the applications, then we have high speed communication. The application is enhanced mobile broadband communication, EMBB, ultra reliable low latency communication, massive machine type communication. Nowadays, you see, communication is not between human being only, it is also between machine to machine. And in machine to machine communication, you can imagine how much faster the data rate should be. Like if I will download some data from a pen drive or from a hard disk to my laptop, you can easily imagine if it takes too much of time for transferring a data of 1 TB or 2 TB, we will be unhappy. It should take as less time as possible. So that is why how it is possible for achieving that we should have a very high speed communication. Then only data can be transferred 1 TB, 2 TB data from a hard disk to a laptop or anywhere else in a faster way. Then what is 6G? If you'll see the different years, like in the mid 1980s, 1G was developed. After that, 1990s, 2G come to the picture, 3G at 2000, 4G 2010, 5G around now also we are using up to certain extent 5G, which is in 2020. And it is expected that in 2030 we will be getting the sixth generation of mobile communication system. So people are working hard how to make this sixth generation to be and but to be useful for the public. Then if you'll see that by that what is the advantage we will get if this 5G is moved to 6G, what is the advantage we can get? That is what you can simple you can see what we are getting the internet facility or the communication facility in our mobile phone, which should be at any place, any time, anywhere and anytime mobile internet should be available. So it may be inside the building, it may be you can see the first figure, which is inside the building. People are using this internet and mobile. Outside the building, also outdoor. Well, the people are walking on the maybe road or on the corridor. It should also they should also get the facility of mobile internet anywhere and anytime. And driving, whenever the people are driving in a car, that also they should get the facility. Also in the subway, the facility should be available as well as the last one is important, high speed train. You know, now we are moving in a high speed train like Vande Bharat and all, where the speed is 100, 150 kilometer. But what is expected that in future, the speed of the train is around 300 kilometer per hour. At that speed also we should get a reliable high speed communication facility. Clear? And that is a major challenge. So for achieving that, definitely you can imagine what should be the data rate and whatever the existing systems available like wire, wireless and everything will not work. Only the solution for it for getting the high speed communication at 300 kilometer per hour speed train is nothing but our simple optical communication. So that is why if any advanced communication system, part of it or the entire system should be optical, then only it can provide very high speed communication. If it is not part of it is optical, it is not said to be it is not said to be advanced communication system at all. And if you see certain applications like every day nowadays, the demands like your Internet of Things, IoT, day by day, the devices surrounding to us all should be connected with internet, as well as autonomous driver. Without driver, the vehicle should move from one place to another place, and how it is possible. For that, you can easily imagine what should be that, how much faster the communication should be. Then only it is possible. In the same way, remote healthcare, if we have a very good doctor at maybe at foreign countries, USA, UK, and in India, we need the consultation, we need the surgery and all. And for achieving that in real time, the communication should be established and the communication should be highly reliable as well as a high speed. Then only we can get remote healthcare facility. The next is our drone-based delivery. Drone-based delivery, everything you can easily imagine very easily that the communication without the involvement of human being. When from one place to another place, all these things will be drawn by drone. And you can easily imagine if a drone has to deliver the what packet or any the device, anything from one place source to destination or one place to another place, you can easily imagine what should be the internet speed, what should be its reliable. If it is internet is available or communication is available, but it is not reliable, then what will happen? The link is failed. Once the link is failed, it will be very difficult to track for the drone. So there is a drone-based delivery means definitely very high speed but communication facility with a very good, you can tell, reliable. So that is why if you will see the pull from user demands from the 1G to 6G, so 6G you can definitely know that much faster, where 10 Gbps peak rate, the latency means delay, should be very less than 1 millisecond. Super connected traffic, which is thousands or 10,000, you can easily imagine, and higher mobility for a speed like 300 kilometer per hour. If a high speed train is there, how you will get the facility. No doubt getting the facility is not the solution, but only getting reliable. The communication or the system reliability should be 99.999%. Means the chance of failure should be very low or it is zero. And if at all the system is very reliable, then only people can accept. You know, when we are talking in a mobile phone, with your friend or somebody, if multiple times the call is disconnected, we will be unhappy. We will be unhappy. Why? Because when no doubt we are getting the connection, but if it is not connected properly, if it is not audible properly, if it has been what disconnected multiple times, we are not happy. So that is why all this reliability, the requirement in 6G or 5G technology is around 9.999%. Similarly, all the devices should be energy efficient. Energy efficient. You can easily know what is energy efficient because energy plays a major role. All the devices surrounding to us are internet connected. Every device requires power. And you can imagine how much power it is consumed. That is why if the devices are not energy efficient, then in future there is no use of it. You know, nowadays sustainable technology plays a major role. Green communication, green technology, all these things are very, very important because no doubt we can get very high speed, highly reliable, and very good communication. But if it consumes very low power, we will not be happy. Otherwise, or you can tell the technology cannot be useful for a long duration of time. So that is why it should be sufficiently energy efficient. Okay, so energy efficient technology. And in simple also you can tell in your mobile you are using. If your mobile battery will over in a what daytime, multiple time, 2 to 3 times you need to charge, then you will not be happy. So what is our requirement that we should use all the applications, all the apps, and the battery should be charged maximum once in a day. Then only we will be happy. And how it is possible? Whatever the devices, applications, and apps we are using, all should be energy efficient. Then only it will be very much useful. That is why if you see the user demands, pool of user demands in 6G means you can tell in 2030 what we are getting all these systems should be completely ultra reliable and as well as energy efficient. Then if you see in simple sense, what is an advanced communication? Power and bandwidth are two important resources of any communication system. I think all of you know for if at all you will go for radar communication, satellite communication, television communication, mobile communication, or any communication system, basically always we will ask how much power it consumes and how much bandwidth it can provide. If the system can provide very huge bandwidth with very low power, what I told you at the beginning, then only it is what acceptable. That is why optical system requires basically very less power and a very huge bandwidth. Bandwidth is in terms of hundreds of terahertz, and it also requires very low power, like LED laser, what you are using, as I told you at the beginning. So that is a laser LED works at very low power, milliwatt or watt of power. Wherever if you go for RF systems like antennas and all, which require very high power in the range of kilowatt, megawatt also, where high power is also harmful to the human body. Uh, There are so many pros and cons, but what I mean to say, if the system consumes very low power, it will be very much what useful for us, as well as it is not also harmful, as also it is said to be energy efficient. And out of these optical systems require very low power because it uses laser and LED and provide very huge bandwidth because basically, it works in 1550 nanometer on 193.1 terahertz. You know, if the carrier frequency is high, definitely bandwidth will be high. So that is why it will be widely accepted the optical system because it consumes very low power at a very higher data. That is why millions of dollars of spend. People, government is spending millions of dollars to put the lightweight communication systems as it results of its performance. Now, and what we are discussed is optical systems, why it is preferred, because it consumes very low power, provides a very huge bandwidth, and optical system means this is what the basic classification. This is not only the fiber optics. Fiber optics is a sub part of this optical communication system. So optical means it may be wireless optical system or it may be hybrid optical system also. And what is fiber optics? Fiber optics is also various types like WDM, DWDM, wavelength division multiplexing, dense wavelength division multiplexing system. And why you are using DWDM? Because the fiber provides very huge bandwidth in terms of terahertz, in terms of terahertz. So for utilizing the bandwidth, basically we are using our DWDM system. Then wireless optical system. Wireless optical is also two types, line of sight and diffuse link. When the communication from one point to another point, if at all it is done without any kind of what reflection, then it is called our line of sight. Front to front transmitter and receivers are available. And if you will see the diffuse link, then the communication is from one point to multi-point. And already I told you, whenever it is from one point to multi-point, the user can get the facility of moving here and there, and he or she can get the facility. So that is why LOS and DL both are equally important for our communication system. Similar, next we will go for hybrid. Hybrid is nothing but a combination of fiber plus wireless. Clear? And in wireless, it may be what free space optics, it may be line of sight, or it may be diffuse link, using which you can able to communicate. And already I told you each and every system has its advantage and disadvantages. Because of which, what we can able to tell that hybrid systems plays a major role because it provides the advantage of both of it and it can provide the necessary requirement. Then if you see the motivation, why people are more talking about optical in the present and next generation, the system capacity and network coverage is expected. How much, what should be the capacity? Capacity means again the data rate. What should the data rate, what is expected? Already I told you, theoretical requirement of data rate is infinity. So that is why if at all we can get higher data rate from the 100 Mbps to 200 Mbps, then 500 Mbps, then 1 Tbps, 1 Gbps and all, then we will be more happy. And theoretically, already I told you the requirement is infinity. So that is why more bandwidth provides very high system capacity. In network, you know, whatever the mobile you are using, it should cover a long distance. If it will not cover a long distance, then you can easily imagine that people will be unhappy. So that is a very high communication as well as very high system and network coverage is expected. And what is why what is the more bandwidth? What are the applications? If you will see the bandwidth of higher bandwidth, one is real-time video conferencing. You want to go for video conferencing with different people, definitely it will consume very high bandwidth. You know, in video in bandwidth is basically in terms of megahertz, whereas in audio it is in the range of kilohertz. That is why if you go for real-time video conferencing, definitely it will require very high bandwidth. Similarly, image transmission from one place to another place, if you will transmit the image, definitely it will consume very high bandwidth. Communication for everywhere, anytime, any place, if at all you want that, then definitely the bandwidth should be very high. Then only it can fulfill the requirement. Similarly, human to machine and machine to machine communication. So it is not that nowadays people are only talking about human to machine communication, rather than machine to machine communication also plays a major role. So that is why you can tell from machine to machine communication, what should the bandwidth? Bandwidth should be very, very high. And no doubt for solving these problems, the basic requirement is the optical systems. But optical system has also a lot of challenges. Like though the optical fiber systems is a very huge bandwidth, like hundreds of terahertz, what is happening? This is because of various effects like nonlinear effect as well as dispersion. The out of hundreds of terahertz, what we could able to use is only 1.28 terahertz till now. 1.28 terahertz TV. So that is why uh, people are working hard how to make that 100 or 1 terahertz of communication to 100 times it should increase. So how do we increase? People are doing a lot of research and it is one of the important area or you can tell the challenge. No doubt fiber has a lot of advantage. The major disadvantage is dispersion and non-linear. What is the dispersion? We will discuss at a later stage. Then similarity. Similarly, if you go for free space optics, because optical means it is not only fiber optics, it may be free space optics also. In free space optics or wireless optical communication, the major problem is atmospheric turbulence as well as attenuation. Attenuation means the signal strength is drastically reduced. Signal strength will be drastically reduced. So that is why for avoiding this higher attenuation, how power will be more pumped or more power can be given so that the system can work for a longer distance. Similarly, turbulence plays a major role. I think you might have now listened to the word turbulence. Turbulence is nothing but change in refractive index of the atmospheric layer because of temperature and pressure is called our turbulence. And no doubt the link is suitable during summer. The same link may not be suitable during winter. Why? Because of the fog and all. So that is why, or it may be suitable during daytime, during night time it may not work. Or it may work during what clear weather, but whenever there is a rain, there may not be any kind of network. The network will fail. For addressing those kind of challenges, so that is why we have to take care about the turbulence. And turbulence, which we will define also later on, is nothing but the change in refractive index of the atmospheric what layers because of the temperature and pressure. And why it is emphasized? Because the light communication basically deals with the refractive index of the, you can tell, the medium. So it is comparing to medium, here if the data and all these things are very high, how it can be communicated. Then these are all known to you, I think, because it is FDP, no doubt it was written. So I'll go through it briefly. That what are the disadvantages and advantages of fiber optics? Definitely, already I told you greater bandwidth, theoretical bandwidth of the fiber is infinity, susceptible to signal delay, degradation. You know, till now, what are the communications available, like wire, wireless, and all? Comparing to all, signal degradation or attenuation is very less in optical fiber, and it is the value is 0.2 dB per kilometer. Clear? So that is what we are using the standard single mode fiber SSMF for a long distance communication is having the attenuation of 0.2 dB per kilometer, which is very less comparing to other wireless as well as wire technology. That is why it is widely accepted. And if it is 0.2 dB means for 5 kilometer, what it is observed that there is a loss of only 1 dB. So that is why you can tell that the loss is very less in fiber optics. Similarly, low power transmitters, already I told you because we are using lasers and LEDs, the power requirement is very low in terms of milliwatt or maximum in watt. So that is what also one more advantage of fiber optics. Similarly, weight is less. All of you know the fiber made up of silica, made up of sand, and where you can easily know because it's made up of sand. It's just like your hair. Huh? Only if you'll see only one hair, how it looks like in the same way. The fiber is also very light. The weight is less. Similarly to radio frequency interference, all of you know the RF technology when you're using a mobile and all, you people use to tech that tell that you should take care of the radiation and all. But in optical communication, there is no chance of what you can tell there is no chance of interference. Why? Because it is a guided medium. Huh? It is non-flammable immunity to lightning. If at all there is lightning effect, also it will not work because it is a guided medium. Impossible tap in a fiber as making it more secure. These are all known to you. Any doubt you can ask me. No doubt fiber has advantage, it has also disadvantage like expensive to install because fiber you have to dig underground cable, undersea cable you might have listened, as well as if you see the maintenance because all fiber optics works in terahertz. You will go for the optical spectrum analyzer OSA or any kind of OTDR, all the devices, the cost is very high because the frequency, the carrier frequency of operation is very high. Definitely the cost will be very high. When you are going to purchase any oscilloscope or spectrum analyzer, people use to have the specification. I think all of you know. And if it works at a very higher frequency, definitely the cost is high. And here, because optical, we are working in terahertz, definitely it is more expensive comparing to other technology. Similarly, termination of fiber. Fiber cannot be joined like twisted cable or twisted wire. So what we have to do? You have to use special what's technology that is called splicing, and we are joining to fiber. So just like what you can soldering of to fiber, fiber is made up of but glass. So that is a two and should be what sold just like soldering. You have to apply proper heat, and you have to that is a specialized technology required for termination of the fiber optics cable, as well as it is for joining. As well, they are more fragile, easily breakable. All of you know, which is made up of sand. So these are all the disadvantages. But by looking to the advantage, where it is providing infinite bandwidth at a very low power, people use to prefer modern communication system. Fiber optics is a part of it. Then only it will be widely accepted. Next, what you will tell about this discussion of the free space optics. Already I told you optical communication means it is not only fiber optics, it may be free space. What is free space optics? You can see here from one building to another building, the communication is established and through laser beam. Through laser beam. That is a free space optics is a wireless communication system. Uses free space is a carrying information carrying will be carried about by the free space optical technology. Clear. So that is why you can see here there is no cable, there is no fiber through air. The laser is pointed from transmitter to receiver and high speed communication is established. And this is what a typical free space optical setup where you can see that there is, now we all are talking about full duplex communication. People are interested only for full duplex. The communication in various types, simplex, half duplex, and full duplex. Simplex only communication is either transmission or reception is possible. Full duplex communication, transmission, as well as reception will be possible simultaneously. I mean, if it is not simultaneous, then it's called half duplex, all of them. But what you require this what free space optics or the fiber optics should be a full duplex communication so that parallelly we can transmit as well as receive the signal. So that is why you can see here we are using two laser beams. One is of red color, another is of blue color. For one is for transmission purpose, another is for reception purpose. That is why we will keep a transceiver at the source as well as a transceiver at the destination. Definitely the full duplex communication can be possible. And why you are using two different wavelengths? For avoiding interference. And why FSO? Why we will not purchase more number of fiber and our what aim will be fulfilled? So the basic answer, what I told you, is the advantage of wireless. The advantage of mobility facility, the wireless has the facility that it can be connected through wireless scenario, so that what you can tell, fiber based system can provide the data rate of greater than 2.5 Gbps. You know, one of the major advantage also you can tell throughout the globe, if you will see, throughout the globe, if you will see about the communication channel distance, which is about thousands and millions of kilometers. eh, and out of all millions of kilometers of communication path, more than 90% are fiber optics. More than 90% are fiber optics. Because for a long distance communication, the best suitable what channel preferred is fiber optics. So that is why fiber optics provides a data rate of 2.5 Gbps for the entire globe. But as it is coming to the user end, like inside the building, the data rate is reduced to 100 Mbps. What you are using in 5G, 4G is 100 Mbps of data rate. So that is why it is. So here 2.5 Gbps is reduced to 100 Mbps. You can easily imagine, or 0.1 Gbps. So that is why you can tell 250 times, 250, around 250 times the speed is decreased, speed is reduced, and that is what one of the major challenge. And how to eliminate those challenge? That is what our what study, or what that is our major concern today. And this problem is basically called our last mile bottleneck problem. So the signal or the information is available till this point. From this point, again, it is comes to the laptop, computer, or any computing device. It takes too much of time. So that should be taken care. And what is free space optics? You can see, imagine that what I told you, like fiber, which is there moving all around the country with a speed of, you can tell, where the communication is in the form of light speed. So fiber optics plays a backbone for the entire system, where it works at data rate of 2.5 to 10 Gbps, where you can see that this is the transmitter and these are the all different receivers. Transmitter and so the red line shows the FSO, phase optics communication, and this is connecting throughout the globe. So that is why here the data rate is around 10 Gbps. But as it will come out, the data rate is decreased and it is like coming very low. So that should be taken care. Otherwise, it will not work. So that is why people are working hard how to make the data rate to be very faster, no doubt by using this optical communication. That is why all optical communication plays a major role. All optical communication plays a major role. Where throughout the globe, the communication is fiber optics, but at the user end, but we are going for the last mile communication, where it should be free space optics. If the free space optics and the fiber optics will combinedly use, then it can provide the data rate of very high speed around 10 Gbps. So that is why that is what one of the major research area also, where people are more emphasizing on all optical communication system. So any doubts in till now, participants, you can ask. If anybody is any doubt, please raise your hand or unmute your mic and please interact. Otherwise, I feel it is only one directional, like simplex communication system, but it should be completely what, bidirectional, full duplex communication. Any doubts? Hello, is it audible?
Yes,
Hello.
sir, you're audible. Yes, sir.
Ah, Madam, all participants are what unmuted? Any? They can ask question at any time. Am I right?
So they can ask the question in the chat box
Okay,
anytime. Yes.
anytime. Okay, acha. So I need to check the chat box also. Huh? Okay.
Yes,
Otherwise,
sir.
anytime you can interrupt me. Not an issue. Huh? Sure.
Yes, so usually they post in the chat. You can, or finally also at the end, you can address all those queries.
Right.
Okay.
And why free space optics? Why not just buy more fiber? Huh? Then you can easily know that already I told you the major advantage of wireless communication is the mobility. And if you will go for this fiber, it is underground cable. You have to dig and you have to go for cost and rights of way, permission, trenching, time, all these things. But FSO, where we can able to communicate transmitter and receiver without no time, huh? Just simply you put a transmitter, simply you put a receiver at the other end, and you can have the communication without further delay. That is why FSO also becoming more important and popular communication during the disaster time. So disaster management system also basically uses free space optics. And if you go for a good communication like 5G or 6G, what is the requirement? Requirement is very high bandwidth. Already I told you which is providing, which can provide very high data rate in terms of Gbps and dBps, low bit error rate. The error should be as less as possible. It should provide high signal to noise ratio, and it should be power efficient, green technology, green communication. Already I told you, sustainable development technology, and it should provide the high data rate. Data security should be very high. Then only it is acceptable. Nowadays, all of you know about the security is also a major concern. If the communication is established, but if there will be some kind of interference, somebody can able to interrupt easily, then that communication will not be acceptable. Then next is our low cost. The cost of the system should also to be very less. Then only it is more what you can acceptable. Like if the cost is very high, people like our Indian, we have very what a lot of middle class family, they cannot able to what effort. That is why cost plays a major role for our advanced communication system. Easy to install and maintain, it is also highly required. And if you see the free space optical communication, which is a major technology in advanced wireless, where you can tell without further delay, and what minutes or within seconds, the communication can be established. Unless like our fiber optics, it is of various types. One is terrestrial, another is space FSO system. If you will show the terrestrial communication system, it is also two types. One is line of sight, another is diffuse link. I think all of you know what is the line of sight. Front to front, the communication is established, and high speed internet or high speed communication is connected. Then it is called our, you can tell simply, line of sight communication. And diffuse link also plays a major role, like during whenever you go for VLC, visual light communication inside the room, inside the building, the communication should be established. I mean, definitely you can easily imagine that may not be the transmitter and receiver may not be front to front always. It may be in a diffuse different angles, how it should work. Then that is called our diffuse link system. And space FSO systems are only LOS, because in satellite, inter-satellite optical communication, the communication or the transmitter and receiver should be front to front. Then only it will work. Similarly, if you see the like our fiber in free space, what the advantage? It is providing very higher bandwidth, no doubt, because it is of a laser communication, and low power transmitters and receivers are used because of this laser. And even if you radio frequency interference, it will not be interrupted. No licensing. One of the major advantages is no licensing requirements or tariffs required for utilization. And the system is small, lightweight, and has compact dimension. Solve the last mile problem of fiber and simplicity of redeployment and mobility facility. Because of this, you can tell the FSO is becoming more popular and it is widely used. Then if you'll see the disadvantages, no doubt, like fiber also non-linear dispersion are the demerit here for FSO. The demerit is atmospheric turbulence, atmospheric attenuation, and pointing error. Atmospheric turbulence, already I told you, change in refractive index because of the temperature and pressure variation. Whatever the link is failed or link is down, then it is called our atmospheric turbulence. Then atmospheric attenuation, it should what basically also providing very high attenuation. The major demerit of wireless is attenuation. Already I told you. That is why for high speed or for a long distance communication, we are using what? Fiber. And pointing arrow, definitely whenever it is not point to point, free space optics. So the law information will be lost. These are all the demerits. And in simple, what is attenuation and dispersion in optical communication? If you'll see, this is a optical signal, light signal, which is here it is showing 1001, 10001. If the amplitude of the signal is reduced after traveling some distance in the fiber, then it is said to be signal is attenuated or signal value is reducing. So, but what is dispersion? That I will transmit 101 at the transmitter, and at the receiver, if I will get 111, then that is called dispersion. Why it is happening 101 to 111? You can see here this figure where we have given input pulse. After traveling some distance in the fiber, what is happening? The pulses are overlapped with each other. Again, traveling some more distance, the overlapping is more. Like this, if it travels for a longer distance, the completely one signal will overlap with other. And because of that, definitely you can tell that this overlapping later on changes the data with 0 to 1. So that is a, if at all I will transmit 101 at the transmitter, it changes to 111 at the receiver. And using this, you can easily know how much the precautions must be taken. Otherwise, information will lost. Because out of 3 bits, here 1 bit is erroneous. But if you see the data rate of 10 Gbps, where we are transmitting 10 into 10 to the 9 means 10 to the 10 number of bits in 1 second. If the error is like in 3 bit, there is one 30% chance of error is there, then that will not be accepted as a communication system. So that is why taken proper care must be taken so that the dispersion effect of this optical fiber should be zero. Or it may not be zero, up to certain extent it should reduce. Similarly, one more problem with this fiber is nonlinear effect. You can know what is nonlinear effect. I think you might have studied. And it is because why you are getting the linear? Because of the light and matter. What is the interaction? It is going on because of which we are getting a nonlinear effect. And these nonlinear effects are various types like self-phase modulation, cross-phase modulation, where variation of refractive index will produce change in the pulse leading to closing to change the pulses frequency approved. And in cross-phase modulation, one wavelength light can affect the phase of the other wavelength. Like our WDM, DWDM, we are getting cross wavelength problem. So that is why, because of the presence of the other signal, if this signal is getting disturbed, then that is called our cross-phase modulation. In the same way, there are so many other nonlinear effects like Raman scattering and billowing scattering. Stimulated Raman, SRS and SBS also plays a major role. If the pump power is very high, no doubt we can travel a long distance. These are all the problems with the higher pump power. And what is this? That the SRS and SBS are over. This is because of these. And SRS and SBS are observed because of the variations of photons in the fiber. And how you can classify or distinguish Brillouin from Raman. Brillouin is extremely narrow, has a bandwidth of less than 100 megahertz, whereas if you go for Raman, the bandwidth is around 30 tera, very huge. So that is why, if at all it provides very higher bandwidth scattering, then it is called Raman. If the bandwidth is very narrow, then it is called our Brillouin scattering. Both the scattering should be eliminated in our fiber optics communication system. No doubt, this scattering may be useful in a sensor, but as far as the communication is concerned, this scattering is not acceptable. And then atmospheric attenuation. Here I have shown the example how the attenuation is changing. Initially, during clear weather, clear sky, it was 6.5 dB per kilometer. 6.5 dB per kilometer. But as you can tell, the fog is increased. Maybe the attenuation increased from 6.5 dB to 150 dB. You can easily imagine how much times it is increased. More than 20 times it is increased. So that is why whatever the link we are establishing today may not work during summer, but during winter it will not produce. And how to eliminate, that is what we will discuss. These are all challenges. And next is your again dense fog, where the you can tell the attenuation is 225 dB per kilometer, which is again very high. That is why this type of scenario also to be noted for achieving the higher communication facility. Similarly, 225 dB per kilometer whenever it is a dense fog in the sense whenever the communication, like you can tell here in dense fog, the chance of laser communication through free space optics will not work because all the signal will be attenuated, and if the signal is attenuated more, the signal will be huge more, and we can able to get it. Then what is atmospheric turbulence? Already I told you it is defined as the fluctuation of refractive index, and y is for the what equation for the delta phi into dn square equals cn square r to the order 2 by 3. And if the value of cn square is in the range of 10 to the minus 7, then it is said to be weak turbulence. If it is in the range of 10 to the minus 13, then it is said to be strong turbulence. So that is why the information will be information will lost a lot during this higher turbulence rather than weak turbulence. Because in higher turbulence, definitely what will happen? The refractive index will change, the laser beam, the scattering signal, the information will be lost. Okay, then we'll go for these challenges of fiber optic system, where we can able to know that no doubt I told you there are two, three, but there are multiple challenges in fiber optics because of which we are not getting all optical communication systems till now. And easily you can know about it. Now, one of the major challenge in fiber optics is fiber nonlinearity. Fiber nonlinearity. Because of this, what SRS, SBS, some Raman scattering, Brillouin scattering, self-phase modulation, cross-phase modulation, as well as four-way mixing effect, the communication is on. We are unable to communicate to a long distance, so that is why it must be taken care. Then all optical communication network. Already I told you the last mile and first mile bottleneck. If at all it can be eliminated by using free space plus fiber optics, then we can tell all optical communication is well established. And then is multi-terabit fiber optic networks. What you're using the communication fiber network, which should able to handle with terabits, and it is not only tera rather than multi-tera. Why? Because it is the theoretical bandwidth of the fiber is infinity, means it can provide very high speed communication facility. And intelligent fiber optic nowadays, you know, intelligent all AI, ML, intelligent systems are very important. Why? Because whenever I will communicate, maybe from this place, this is what from you are now I'm staying in Raipur. From Raipur to Delhi, I want to communicate. Then which path I need to follow so that the communication will be faster, cheaper, and all. For achieving that, what you have to do? You have to go for intelligent system. Now you know if at all the neurons, networks, even if at all he is having the AI models are incorporated in the fiber network, then only it is said to be intelligent. If the proper path, shortest path, as well as optimized path can be found, then definitely the link will be most faster. That you need to take care. Then optical neural networks. That is why the basic building blocks of any intelligent network is nothing but neural networks. The development of neural networks also plays a major role. Improvement in optical amplification technology. What are using the amplifier like alpha or maybe any kind of Raman or Brillouin, all this amplifier technology must be well developed. And what is the problem with amplification technology? No doubt we are getting a very high good gain or very high gain in amplifiers. But what is happening is the gain is not stable for a wide range of frequency, because in DWDM dense wavelength division, CWDM coarse wavelength division multiplexing, we are transmitting around 100 or 200 terahertz of bandwidth of data. And where you can tell the amplification plays a major role, because till now what the amplifiers it is developed is works maximum flat up to 35 or 40 kilometer, not more than that. 30 to 40. What it is required in future is very high. So that is why it must be taken care. Next is long haul fiber optics. You know, throughout the globe, the fiber optics cable is laid maybe underground, maybe under sea, or those kind of cables. So that is why uh, long haul communication plays a major role. Then also advanced modulation. Modulation also plays a major role in optical communication, because by using which you can tell where the nonlinear effect is arise, where the power is moved, and all you can able to know about it. Then equalization technique, any communication, if at all at the receiver side it is unable to provide the necessary SNR, then in simple, the solution is various use of coding technique using equalization technique as well as advanced modulation technique. So that is what I mean to say. Each and every points are nothing but the challenges of fiber optic system, and each and every topic will lead to one PhD. So people are working hard how to make the fiber optic systems to be in real time in communication area in seventh generation or sixth generation or maybe in advanced 5G technology. Similarly, if you go for challenges in FSO technology, which is fixed optics or wireless optics or and without fiber the communication is established. Here for there is also different types of link like terrestrial means ground based link, and another is underground cable and all. So what the challenges in FSO technology is absorption and scattering. It is providing very high attenuation, uh, and what atmospheric turbulence, beam divergence, whatever the beam we are transmitting because of the pointing error or mismatching between transmitter and receiver, what the signal or information is lost, that is to be taken care. Next is misalignment or bending wave when there is no point-to-point system, point-to-point communication system, it is really going for misalignment and pointing error. So that must be taken. That is why these are all challenges in FSO. Next is ambient light. What I told you, the background light so produces a major demerit. So that is why how the ambient light, if at all in the presence of ambient light, also we can able to do the communication facility. That is also the major challenge. Then if you see the space link, the major demerit is pointing because the transmitter and receivers are very long, thousands of kilometers. Right, that is why pointing towards the what the and next stage, atmospheric attenuation. All of you know the space links also at 1550 nanometer. There are 10 nanometer, 13, 10 nanometer. We are having the attenuation is very high. No doubt in fiber, the attenuation is 0.2 dB per kilometer. But in FSO, the attenuation is very high, which must be taken care. Then background noise, how like FSO, which is works in you can tell during daytime or during night and all. So that is why during the we are using various lighting technology with this what presence of light, sunlight as well as other light. How the communication will be properly established. That is also the major challenge. Atmospheric seeing as well as angle of arrival fluctuation, these are all you can tell comes under also pointing error, which means pointing loss. Then no doubt certain what challenges you mentioned, there are various mitigation techniques. No doubt the all the challenges could not be addressed, but up to a certain extent, it has been mitigated by using various what advanced signal processing techniques. And out of that, one of the major is in optical is advanced modulation and coding techniques. Basically, nowadays, so many hybrid modulation techniques come to the picture. Phase modulation, frequency modulation, MSK, minimum shift keying, as well as QAM. And people are talking about if you go for the coding like CSRZ, NRZ, and DRZ, MDRZ, modified Neo binary return to zero. All these coding techniques, advanced coding techniques, plays a major role for providing this mitigating. Then FWA minimization. one of the major demerit of this four-way mixing, and how this four-way mixing effect can be mitigated. That is what the major challenge. And this is what you can tell that what is in simple the four-way mixing. If at all we are transmitting two signals in the fiber, I will show you one more here. If you will transmit two signals in basically in fiber, if you transmit more than one channel, then it's called multiplexer system. If I transmit two signal, two wavelengths, one is 1550 and 1551, maybe with 1 nanometer distance, two signals are transmitted. What is happening after traveling a distance of certain maybe 50 kilometer or 100 kilometer? With these two, another two signals are here generated, and these extra two are undesired. All of you know these two are only required. These two extra two are undesired, and because of the two signals, which is producing another two extra, which is called our four-way mixing. That is why the equation how many undesired or spurious noise signal generated is given by m equal to n square into n minus 1. If you put the value of n equal to 2, it is 2 square into 2 minus 1 is 1 by 2. That is 2 by 2 is 2. That is why if n equal to 2 means input there are two signals, another m or two number of spurious or undesired signal is generated. So that is why if you put the value of n is very high, because in a single fiber optics, millions and billions of telephone calls, video signals are transmitted. So that is why if the value of m is millions and billions, definitely you can able to understand how many undesired signals are produced. So that is why for taking care of this four-way mixing if it is a major challenge, and how it can be mitigated for avoiding the disturbance in the information or in the communication system, how it will can provide very high speed data rate as well as very long distance communication is a major challenge. So this is what I have shown you, that how the FWM effect, that when I will transfer two signals and the two undesired are generated. In the same way, typical fiber optics setup, if you will see for analysis of this FWM effect or maybe sulfate modulation, cross phase modulation, different types of nonlinear effect. This is what a typical setup in optic system software, where you can see we have a laser source, MZ modulator, RZ pulse generator, PRBS, and all are there at the transmitter side. And these signals, these are all at the receiver, where we have the pin diode, low pass filter, and BER analyzer. In between transmitter to receiver, we have the fiber, optical fiber, which is producing the necessary communication facility. So that is why what I mean to say, the typical fiber optic system using optic system software is nothing but the transmitter and receiver. The transmitter contains PRBS, RZ pulse generation, and MZ modulator and CW laser, whereas the receiver we have the pin diode and filter and the iodide analyzer. And the communication is established with the fiber length of 50 kilometer, and we have connected here two OSA at the after 50 kilometer and 50 kilometers, so that we can able to observe the four-way mixing effect very easily. Okay, I think it is clear. Any doubts till now? Let me see the chart. Any doubts? Okay, no doubt, no messages, I think till now.
Sir, no messages till now.
Okay, okay,
I
nice.
suggest all the participants to write their questions in the chat box so that Professor Patnaik can address those things.
Right, it will be more interactive also.
Yes, yes,
Otherwise, I
yes.
feel talking in front of the wall, just like
No,
nobody.
there are a lot of
So that is
participants,
what
sir,
I
attending.
thought last 1 hour I'm talking. So that is why if there will be some interaction for 5 minutes, it will be better. Otherwise, they will feel bored also. Only listening is very tedious. Right, Nanda sir, what I feel, let them ask some questions. Otherwise, we will have a 2 minutes of break. Again, we will start it.
Sir, how much time, how many slides you are planning to cover?
So I think I am moved up to half, I think. No doubt, maybe by another 30-45 minutes, I will finish it.
Okay, sir. Okay.
Maximum, it is now around 5:02. I will conclude by 5:40, sir. Anyway.
Okay, okay. Sure, sir. Participants, you can able to write your things in the chat box.
I need only
Okay,
2 minutes
sir,
of
you
break,
can
then
take
we will.
little break and then you can resume, start the thing.
Yes, yes, sir. Yes,
Yes,
sir. Yes.
yes. Okay, sir.
Thank you. Thank you. We'll start sharp 5:05 again. It is 5:02
Sure,
now. Maybe 3 minutes of break. Huh?
sir, sir, sure.
Thank you. Okay, welcome back to all of you. What I feel, we will resume, we will start it. Okay, this is what a typical fiber optic system, which is a simple setup which I have shown. Later on, because of the huge bandwidth of the fiber and what basically we use to go for is our DWDM system, dense wavelength division multiplexing system, where only we are getting that the four-way mixing effect as well as other nonlinear effect. And that is what the major challenge, what I have told here. We have shown a typical setup of 64 channel, lambda 1 to lambda 64, and we will see how this channel, because of this 64 channel, how the communication is established. So that was the what you can tell. This is the basic setup by using operating system software. How the DWDM system is what then here you can see this is what again the same like single channel system. One PRBS, RZ modulator, CW laser, and MZ modulator. These four blocks are repeated here for channel number 2, for channel number 3, channel number 4, like this 64 channels. All are connected to this ideal mux to a multiplexer. Then it is given to the what loop where we have a single mode fiber, erbium doped fiber amplifier, then amplifier which is amplifying the signal. Then we are using a dispersion compensated fiber, and at the end again a amplifier where erbium doped fiber amplifier, and we are reconnecting it with a you can tell demultiplexer, and demultiplexer will produce single to multi, and what the signal four signals are multiplexed. Here it is again retrieved, and for each and every channel we should we are here having a photo detector, and we have a low pass filter and BE analyzer, which is for analyzing the system performance. So for FWM analysis, what I told you that nonlinear effect, which is a very important concern in WDM, DWDM systems. So what that how it is to be analyzed? We have using a WDM transmitter where we have 8 channels. All are given to the multiplexer, and the multiplexer output we are connecting a fiber. After 50 kilometer, we will see the spectrum, and before transmission of the signal through the fiber, also we will see the spectrum. Then we need to compare this spectrum with this. And if you compare after 50 kilometer and before 50 kilometer, what is the spectrum, we can able to know how this FWM plays a major role in case of our information, which is lost because of the what long distance traveling of the signal in a fiber. So you can see here this for this setup, what I have shown here. So this is what the spectrum it is observed after 50 kilometer. You can see at the transmitter, we have transmitted the signals which is showing live one by one line. It is a 64 channel basically. 64 lines are available at the receiver. You can see after traveling the signal to 50 kilometer, it is not like the simple, you can tell distinguish lines rather than so many signals are overlapped, and this overlapping is a major problem. And why it is overlapping? Because whatever the spurious signals it is generated, the frequency what I told you is F1 plus F2, a plus F3, or F1 plus or minus F2 plus or minus F3, like this, it is producing so many undesired signal. So if the undesired signal will overlap with the original signal, then SNR will drastically reduce. So that is why it is to be taken care how this FWM effect minimization can be done. As well as also we have seen so many sidebands at this with this available signal spectrum, and these sidebands can be eliminated with the help of filter. It doesn't matter much more, but the major concern is these thick lines, 3 lines, whichever it is visible. These are all nothing but the spurious signals overlap with the original signal, and it must be what minimized. Otherwise, the information will be lost. The next is the same signal spectrum where we have changed the power. The power it has been taken is 20 dB and minus 10 dB. 20 dB, we can see here the spectrum, what it is observed, the lines, the spurious undesired signals are around minus 10 dB. Whereas in case of our minus 10 dBm, the spurious signal value is around minus 60 dB power. So that is why you can tell figure B is better here comparing to figure A. And figure B is better means the system should the system power should be as low as possible. But if the power is also too low, what will happen? It cannot be traveled a long distance, and it also what will happen if cannot travel to a long distance, it will also produce lot of what multiple times you need to have the amplifiers, repeaters, and all. So that is why it must be taken care that the amplifier and filter should not be used multiple times. That is why for avoiding or for minimizing this nonlinear effect, the input power should be as low as possible. But the input power is too low, then multiple times you need repeaters. Similarly, if you go for different coding techniques like CSRZ, MDRZ, Fourier suppressed return to zero, modified duo binary return to zero, carrier suppressed, and if you see here the WDM analyzer diagram, where OSNR here it is found is 29, 28, 30 dBm around. Whereas in case of right hand side is 33, 32, 35. You can see here basically the power is 3 dB. The OSNR is 3 dB more from in MDRZ comparing to CSRZ, which clearly shows that MDRZ provides better result. MDRZ provides better result compared to CSRZ. So that is why preferably MDRZ should be used rather than. But the demerit of MDRZ is again the complexity. But now, because of the development of the technology in a faster rate, you can tell the what MDRZ or you can tell the DRZ, the complexity, we should not bother. We have to bother only for the OSNR. Where if the OSNR provides very high, then that coding technique will be more preferable rather than the previous one. Then similarly, if the table here it is shown that FW various input power, it has been various input power has been taken starting from minus 10 dBm to 20 dBm, minus 10, 0, 10, and 20. Here you can see the approximate FWM sideband power is minus 59 and minus 41, minus 20, and minus 12. So out of which you can tell or you can know easily that sideband power should be as low as possible. That is a minus 10 dBm input power, where the spurious signal the minus 59 is more acceptable compared to 20 dB, where the spurious signal is minus 12. So that is why in fiber optics DWDM system, the input power should be as low as possible. But again, the input power is too low, means again it requires multiple repeaters. Similarly, for varying channel spacing, if you vary the channel spacing from 25 gigahertz to 200 gigahertz, you can see the sideband power varies from minus 36 to minus 39. Minus 39 is well acceptable, where you can tell easily that the channel spacing of 200 gigahertz, channel spacing of 200 gigahertz. But if the channel spacing is too high, again DWDM system will require a very wideband amplifier. So that is why channel spacing cannot be too high. And if it is too low, like 20 dBm, definitely the FWM power will be what very high. So the nonlinear effect will be very high or the noise will be very high. So that is why it must be taken care. And FWM effect for varying cross-sectional area, if you change the cross-sectional area of the fiber from 64 micrometer square to 80 micrometer square, then FWM power is increased from minus 39 to minus 14, which shows that if the cross-sectional area is very high, it is good. But if it is again too high, single mode fiber will be changed to multi-mode fiber. And you know the multi-mode fiber is not good for long distance because it provides very high attenuation. So that is why it is also an what you can tell matter. So we thought that the cross section area should not be so high and should not be so low. So here it comes the optimization. What should be the value of the cross section area? So that the FWM power should not be very high, as well as the attenuation should also to be very low, like single mode fiber, which is around 0.2 dB per kilometer. So that is why finally we can see that if you will see the DWDM system as a function of power, then the input power, whenever it is varying, the FWM effect is also varying, like channel spacing, various modulation formats. If you go for various CSRZ, DRZ, MDRZ, it is providing different and effective. So these are all the parameters based on which the FWM effect is varying. And now, if at all, this is what regarding this only nonlinear effect. But if you see the dispersion, where the pulse broadening it is observed, that if without dispersion, you can see the eye diagram is completely distorted. And if you go for some kind of dispersion compensation, there are various dispersion compensation techniques available in the literature. And if some of the dispersion compensation technique, if you go through it, and if the dispersion compensation technique is not used, then the eye will be completely distorted. If there is a dispersion component like what we are using a symmetrical dispersion compensation, fiber Bragg grating dispersion compensation technique, pre-dispersion compensation technique, post-dispersion compensation technique. So that is why by using that you can see that the eye is better comparing to without dispersion. So I think all of you know about the eye diagram that but when you are transferring the zeros and ones in digital communication, maybe in case of fiber optics also you are transferring zeros and ones. Ideally, the eye should be a rectangular box. Whenever the same thing is received at the receiver as it was at the transmitter. But because of the rise time, fall time of the pulse, what is happening? The rectangular box shape change to human eye. That is why the diagram is called eye diagram. And it is that the at the center, well, the width between or the difference between high and low should be very high. If the difference between high and low will be very high, definitely you can tell the SNR will be high. Otherwise, the signal to noise ratio will be less, which is not acceptable. Next, if you'll see the same analysis for this fiber optic system, so you can easily know that the Q factor, how it is affecting, hmm, and Q factor is nothing but the variation of this. Hello. The difference between mu1 and mu0, mu means mean value of the what data rate 1 and data rate 0, and sigma 1 and sigma 0 is nothing but the variance of this data rate 1 and 0. If the difference of this amplitude some 0 and 1 is very high, then only the Q factor will be very high. But if the variance is very high, the Q factor will be less. So that is why Q factor plays a major role, quality factor, which will show us that what should be the value of what or what should be the acceptable value for our communication system. You know, Q value of 6.8 or 7 is widely accepted for optical communication because which provides a B, the equation is already given here, e to the power minus Q square by 2 divided by Q root 2 pi, by using which you can easily know that BER of 10 to the minus 9 means in 1 second, if 1 Gbps data is transmitted, 1 Gbps data is this data rate of this communication system. In 1 second, only one error is tolerable. Then that is called BER of 10 to the minus 9. So that is why you can see here that as the input power is increasing, Q factor is increasing up to certain level, like around 2 dBm or 3 dBm. But after that, if the input power is increased, then Q factor is decreasing. Q factor is decreasing. This clearly shows that what I mean to the quality factor shows that is better whenever the power is around 2 dB. That is why in a fiber optics DWDM system, if the input power is too low, it is not good. If it is too high, also it is not good. If it is too low, definitely signal power will be less. If it is too high, core mixing or because of the non-linear effect, the quality factor will be deteriorating. And again, here it is compared with the different you can tell coding techniques like MDRZ, DRZ, and CSRZ. Here you can see MDRZ provides better result comparing to DRZ and CSRZ. That is why MDRZ is widely accepted comparing to DRZ. And so you can go for any advanced like you are hybrid nowadays. So many hybrid coding techniques are also available. That also it can be used for it. Now, similarly, if you go for the dispersion compensation technique, there are symmetrical pre and post dispersion compensation techniques. It is widely used in literature. And out of this out of these three dispersion compensation technique, it is here this observed that the quality factor is better for symmetrical dispersion compensation rather than pre-dispersion compensation and post-dispersion compensation. Because in symmetrical dispersion compensation technique, what we used to do? We used to keep the DCF in between two single mode fiber of 25 and 25 kilometer. So that is why what is happening, the fiber broadening is going on. Again, it will what narrow down. Again, it will broaden, and so that is what the you can tell before the signal is disturbed completely. What is happening? It is coming back, or it has been retrieved, or it has been data has been regenerated. So that is why you can tell the symmetrical dispersion compensation technique provides better result comparing the pre and post. No doubt FVG fiber bracketing also provides better result in case of our what optical systems, but that is only suitable for our you can say single channel system. But if you go for DWDM, CWDM, always the better is symmetrical dispersion compensation taken. Similarly, if you see the eye penalty, what is eye penalty? Eye penalty with respect to distance. Eye penalty means the eye height should be age in the penalty the eye height is less, and that is why the penalty should be age loss is possible. You can see here there are different channels: channel number 1, channel number 32, and channel number 64. Out of that, the eye penalty is less for central channel, which is channel number 32, and the channel 1 and 64. The eye penalty is very high. The eye penalty is very high. So that is why what I mean to say, the center channels provides better information rather than the add channel like 1 and 64. And that is why what is happening, you can tell in fiber optics communication system, the center channel frequency should be 1550 nanometer, as well as the information which is very, very secure should be transmitted to the center. And why you are the border which is providing low or low Q factor or high penalty, high penalty, because what you are getting the FWM effect or the minimization is not proper at the edges rather than at the center. Similarly, after that analysis of this what dispersion, eye penalty, as well as this what Q factor, you can easily see about this hybrid optical communication systems. Already I told you the fiber has the advantage of long distance communication problem, as well as DL is suitable for multicasting purpose. So that is comparing, considering the advantage and disadvantages of the system, hybrid optical communication systems are proposed, where it is the part of it is DL, part of it is fiber, and combination of DL and fiber provides us a hybrid optical communication system, because of which we can go for long distance communication also with a multicasting applications. So this is what the typical setup of hybrid optical communication system. You can see here we have connected so many diffuse link setup here, starting from channel number 1 to 64, where we have the transmitters and it is being modulated by MDRZ modulation, having different wavelength lambda 1, lambda 2, lambda 64, different wavelength is chosen for avoiding interference. And after that is given to the multiplexer. Multiplexer output is given to the fiber amplifier as well as optical spectrum analyzer, and at the end it is connected with the demultiplexer, and the reverse operation has been done at the, you can tell, receiver, like MDR the demodulator and DL diffuse link to what lambda 1 to lambda 64. Again we are retrieving the data here. For single mode fiber it has been taken 50 kilometers, DCF it is taken 20 kilometers, and A1, A2, A3 are the amplifiers which is having alpha, having gain of 10 dB. So you can see here with these different I diagrams, that I diagram and Q value for channel number 1 at 100 giga channel spacing, 150 kilometer and 500 kilometer. You can see at 50 kilometer the eye was more clear, but when it travels to 500 kilometer, because of the non-linear effect and dispersion, what is happening? The eye the signal or the information is deteriorated. In the same way, if you see the channel number 1 with a channel spacing of 25 gigahertz, previously it was 100 gigahertz, it is more better. For 25 gigahertz, again it will be more worse because of the FWM effect. And at 50 kilometer and 950 kilometer, you can see the eye is better watch at 50 kilometer rather than it travels 950 kilometer, the signal is distorted. So that is why always it is preferable that channel spacing should be as high as possible, as well as if it travels a long distance, the information can be retrieved properly. This is what the FSO setup, where we can see different diagrams with respect to again the coverage distance, input power. If the input power is increased, definitely the coverage distance will be high. And you can see out of these three modulations like coherent optical, QPSK, NRJ and RJD. Here we have compared PSK technique with what I mean to the different signal processing works has been done, and we are comparing which is providing better result. You can see here QPSK provide more result, more better comparing to NRZ and RZ. You know QPSK is a coherent technique, And in current technique, definitely the SNR will be high. If SNR will be high, coverage distance will be high. It will also provide a higher data rate. And if you will go for NRZ and RJ, these are all OOK techniques, on-off keying techniques. And on-off keying technique has a demerit, like it is more noisy and it may require adaptive threshold and all. That is why you can tell here in simple that as the input power is increasing, coverage distance is very good for QPSK rather than NRZ and RZ. So that is what coverage distance. And there are two types of setup here. What I in a hybrid setup, one is line of sight, another is diffuse link. And no doubt for our point to point, we are using line of sight free space optical systems. And if you go for diffuse link, where what single to multiple or multicasting we are using, you can see in diffuse link the coverage distance in terms of meters around 120 to 160 meters maximum. No doubt again the QPSK provides better result. Whereas if you go for this LOA setup, the distance is in terms of kilometer to up to 2.2 kilometer we could able to get it. Where here it is hardly a matter of 160 to 200 meter. That is why the line of sight provides definitely higher coverage distance comparing to the diffuse link setup. In diffuse link, we are not getting better result because of these reflections, refractions, scattering and all. But diffuse link setup is good. Whenever we will have a, you can tell in simple line of sight fails, line of sight fails, or you can go for a single point, multi-point communication system. If it will go for this only point to point, like lead line connection and all, we can go for line of sight communication system. And QPSK, it has been observed that it provides higher spectral efficiency as well as low beta error rate comparing to other like BPSK and 8PSK, FSK. So that is why here preferably QPSK has been taken. You know, out of all digital communication system or digital modulation systems, so QPSK is more preferable because it is what better in terms of bit error rate as well as spectral efficiency. No doubt the constellation looks like what, 4 points only, but it provides very high spectral. If you means in one symbol, you can able to 2 bits. That is why. But the major problem again is power and is regarding the local oscillator, which should properly synchronize with the received signal. If the local oscillator signal is not synchronized properly, then there is a chance of various noise as well as we have to use proper IF intermediate frequency, and the IF should not be too high as well as too low. If it is too high, again the problem of nonlinearity, and if it is too low, what is the chance of disturbance or interference is very high. So that is it should not be too high and too low as far as the communication scenario. So that is why comparing means taking into the consideration of signal processing as well as performance parameters, to have coherent optical QPSK is more preferable for line of sight as well as diffuse link, line of sight and diffuse link setup, so rather than this OVO category. Okay, so I think I don't want to take more time because I think since morning you people are listening. It is don't like to take more time. I will be taking some questions if required, if at all anybody here. What you can conclude here in simple 5G, various wireless technologies and vision, and what I told you also, basically in simple, when communication experts, you will see different higher generation means it is providing higher data rate as well as consumes low power. Basics of optical system, the challenges we have discussed, fiber optic system is for high speed, long distance. FSO is suitable for last mile problem. That is why combination of fiber and FSO is what discussed here, proposed here, and it is discussed where it is solving the problem of what last mile as well as long distance communication system. So these are the references like what you can tell GP Agarwal, which is a very famous father of fiber optics. So many books, and you can go through the references where it has been collected. Okay, I think I have done from my side. I have completed. I told 540, but 5:31 itself, I'm planning to close the talk. And any doubt, any questions, I will be happy to take for another 10-15 minutes if anybody is having. No doubt, last session is very pathetic for the mm, what participants. One question is there. Does it support QAM for higher order in place? Yes, QAM is also widely used. But in what is the problem with QAM is in optical we have a very what higher frequency, like in terahertz we are dealing. So dealing with the terahertz as well as quadrature amplitude modulation constellation and having this phase noise is a major important concern here. So that is why it is being widely not used. It is used no doubt up to a certain extent QM in research, but widely used is only QPSK in optical. Further advanced like no doubt in wireless it is used, but in optical we are restricting up to QPSK. And after that, so many variants of QPSK are also available, like high fiber shifted QPSK, offset QPSK, DP QPSK, dual polarization, quadrature phase shift king. Those are all widely used rather than QAM. Huh? Thank you very much for session. Okay, thank you. Thank you. Only what are the benchmark of Q factor? And right, very good question. This is what is the benchmark of Q factor? You see, in optical, what you are using the data rate is minimum 1 Gbps. 1 Gbps means 10 to the 9 bits per second. In 1 second, 10 to the 9 bits means the error should be 10 to the minus 9. Means in 1 second only there should be one error. That is why the BER acceptable is 10 to the minus 9 to minus 12 in optical communication. Concern with it, the Q factor, as I have given the equation, is around 6.8 to 7. And if the Q factor is more than 7, it is widely accepted. And when you will design the system, you have to check always if the for all the channels like 64 channel QPS, 64 channel DWDM system, all the channel Q factor should be more than 7. Then only it is accepted. If it is less than 7, it will not be accepted. Yes, thank you. Any other questions? I think what of the it is there in the chat box. I have answered. Okay, thank you, Dr. Paresh. Any other questions?
Sir, you can on-share the slide
Yes, Nanda sir, please.
and make the video on, sir.
Acha, video. Okay, sure.
Yes. On-share the slide. Yeah.
Right.
So there is just one more question.
Yes,
Physical
sir.
interpretation of Q factor.
Physical interpretation, right? Q means quality factor. You see, already I've given an equation here in slide number. Yes, slide number 46. So Q factor is nothing but the difference between mu1 minus mu0. Means what is the amplitude of data bit 1 and minus the amplitude of the data bit 0. We have subtract the absolute value divided by the what variance sigma 1 becomes but not standard deviation sigma 0. So that is why if you will see the interpretation, physical interpretation means higher Q value indicates that the difference between the amplitudes of the data bit 1 and 0 is very high, as well as the variance is less. So that is why if the difference of amplitude of 0 and 1 is high, we can at the receiver we can easily distinguish which is data bit 0 and which is data bit 1 by taking a threshold value. So that is why the physical interpretation is Q factor is high means that we can able to distinguish high and low very easily rather than what maybe otherwise it is difficult. Yes.
Another question
Yes, sir.
in the
Yes.
chat.
I was getting. Does FOC support 5G MIMO? Yes, already MIMO technique is also available in free space optics. People are also working on it, multiple input, multiple output. Those are all also used in higher data rate as well as I have not focused till now in MIMO. Only we have seen about this till now the multiplex like DWDM, CWDM only I have emphasized. How does the Q factor relate to the overall quality of the optical communication? Yes, Q factor matters everything. You can tell in simple. If you can if I will transmit a data at maybe at your Raipur, you are listening at now maybe in Mumbai, Delhi or Jaipur. If you can able to distinguish 0 and 1 very clearly by using a threshold, then it is done. We have information is retrieved. So that is a Q factor provides a more informative. And if you are not getting proper Q factor, how to get Q factor more than 7 as per the FEC threshold, that you have to go for other analysis like maybe spectrum analyzer, maybe OTDR, maybe power meter, any other analysis will also helpful for you. But ultimately, the basic thing which is or the important thing you can tell is Q factor, which should be taken care and for providing the better quality of information. And one thing you remember that in all multiplexer system, for each and every channel, the Q factor should be more than 7. If it is less than 7 for any one channel also, information is allowed for that channel. That must be taken care. Yes, please. Any other questions? I think I've answered. Any other doubts you can ask also.
Sir, I can see there are no further questions.
Right. I think since
Uh,
morning they're listening a lot, they might have tired also. Speaking is very easy, but listening from the other side is very
Yes,
difficult. We
yes.
do agree for
I'm
it.
thankful to all the participants for interacting with Professor Patnaik. So I'm thankful to Professor Patnaik for giving such a wonderful session and explaining each bit by bit to all the participants. And thank you very much, sir, for
Thank you.
this very nice session.
Thank you, sir. Thank you. Thank you all participants for patiently listening. Any doubt, you can reach to me by over maybe mail or I will share the PPT with Dr. Nanda sir also. You can collect if at all is required for further reference. And I think I should thank to Ravi sir also. Ravi sir is
Yes,
maybe busy with other works, I think.
sir.
Okay. Please convey my regards to him. Okay.
Sure, 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 sir.
Thank
Thank
you.
you, sir. Thank you,
Thank you. Thank you a
participants.
lot, sir. Good day. Good day. Good day to all of you.
Thanks. Thank you. Uh, Participants, we will have a quiz for today. It is scheduled. So we will give you enough amount of time in the weekend, that is tomorrow and on Monday. So quiz will be taken on the Canvas platform itself. So you should look at the quiz number 1, which will be starting tomorrow onwards, and it will be there till Monday. And you can take, once you start the quiz, then you can, the quiz will have a limited time. Okay, that is half an hour. So within half an hour, you can able to answer the quiz. And anytime you can start, and uh, anytime you can start, and you can finish within half an hour. So the quiz will be there tomorrow as well as day after tomorrow, that is Sunday and Monday. On this entire topic, whatever has been taught till date by the various speakers, there is a very uh, the link of the quiz will not be shared. The link, once you open your Canvas platform, in the Canvas, like you are getting your things, materials, similar way quiz will be posted in the Canvas. Yes, quiz will be posted in the Canvas, and you have to answer in Canvas platform only. Okay. So thank you, everyone. Thanks. So here we conclude the session for today. Thank you, everyone. Tomorrow is a holiday. Sunday we do not have any session. So our sessions will be resumed on Monday.